Okay, so we are now looking at Unit 3.7 practice problems. If you watch the daily video, you know that this is just molarity stuff. You're going to be working with the molarity equation, which of course is molarity equals moles over liters. And there are some questions where you could use M1V1. M1V1 equals M2V2. In fact, if you watch the daily video, that first problem she did could have been done so much easier with M1V1 equals M2V2. So anyway, let's take a look at these. One of the things they really like to do is break out cation or anion when there's more than one in a compound. So how many moles of sodium ions are in 100 milliliters of 0.1 molar sodium phosphate? So of course 0.1 molarity times 0.1 liters is 0.01 moles, but that is of the sodium phosphate. Come down here. All right. But every sodium phosphate is going to break into 3 sodiums. 3 sodium cations, and of course the phosphate. So instead of 0.01, it's going to be 0.03. How many grams of calcium chloride are needed to prepare 100 milliliters of 0.1 molar chloride solution? So again, it's now I've got a little more room to show my work. 0.1 molarity times 0.1 liters. That again is 0.01 moles, but every calcium chloride that breaks into 1 calcium 2 plus and 2 chlorides. So this would be 0.0100 moles calcium chloride, and we get 2 chlorides for 1 calcium chloride. So the answer is going to be 0.02 moles, and then we got to multiply by the molar mass. So 0.02 times 111 is going to be 2.22 grams. There we go. What volume of water must be added in order to dilute 40 milliliters of 9 molar HCl to a concentration of 6 molar? How much water must be added? So they're never going to give you an easy M1V1. They're always going to make you think about what it is they're asking. So M1V1 equals M2V2. We are starting with 9 molarity and 40 milliliters, and we're going to 6 molarity. So 9.0 times 40, it would be 36. Is that right? Divided by 6 is going to be 6. Hold on. Let me do this on the calculator. 9 times 40 divided by 6. 60. Our V2 needs to be 60. And of course, they have that sitting right there waiting for you. But that's not the question. The question is how much water must be added. So we're starting with 40 milliliters. We only need to add 20 milliliters. Okay? Look for tricky things like that whenever an M1V1 is called for. What volume of 0.1 molar HCl stock solution should be used to prepare 250 milliliters of 0.25 molar? I can tell this is a fairly new question because you can't really do it very well without a calculator. 0.025 molarity times 0.250. I didn't need to, I'm doing M1V1. I can stay in milliliters. 250 milliliters equals, and actually that should be, okay, I'm starting over on this one. Sorry. M1V1. Okay, my M1 is 0.001 molarity. I need to know what volume of that's V1, do I need to make 250 milliliters of 0.0250 molarity. Okay, so I'm going to multiply that out. 0.025 times 250 divided by 0.1. I should have been able to do that in my head. 62.5. So I said they'd always be tricky. That one was pretty straightforward. And you see how I started with what really should have been my M2, V2 on the left? It doesn't matter. Obviously, it doesn't matter if that's on the left or the right. The main thing that matters is anything that's connected with the word of needs to stay together. Okay, a student prepares a solution by dissolving 60 grams of glucose in enough distilled water to make 250 milliliters. The molarity should be reported as, so we got to do a grams to moles. 60 grams divided by 180 grams per mole. So this is 1/3, right, one third of a mole. So 0.333 moles divided by 0.250 liters. Let's see here. 0.33, boop, 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 boop. 0.33 divided by 0.25. I get 1.3, 1.332. There it is. Oh, look, this is a sig fig question. Notice, we did not do any addition or subtraction in here. All I did was I divided here, and then I divided there. So my answer needs to be given in the least number of sig figs up there in that question, assuming all these numbers were used, and they're all in 4 sig figs. The answer is C. Okay. Which of the following is the best method for preparing 100 milliliters of 1 molar KCl? Okay. One thing you need to know, whenever they give you a problem about making a solution, you need to be sure if they give you the option to use a volumetric flask, use a volumetric flask. So I'm liking either C or D. Let's see. C says put 7.46 grams of KCl in a 100 milliliter volumetric flask, partially filled with water. Swirl the flask to dissolve. Fill to the 100 milliliter mark with water and invert several times. Okay, I like that one. Let's look now at D. Place 7.46 grams of KCl in a 100 milliliter volumetric flask, partially filled with water. Swirl flask to dissolve. And then it tells you to add the specific amount. The reason you use a volumetric flask is because they have those marks on them, and you want to fill to the mark. There you go. Okay, here we go. Boop, boop. Can I get over there? Where's the rest of this thing? Is that it? Oh, here we go. For an experiment, a student needs 100 milliliters of 0.4220 molar sodium chloride. He starts with sodium chloride in distilled water. Which of the following pieces of laboratory glassware should he use to prepare the solution with greatest accuracy? We want the 100 milliliter volumetric flask. There it is again. Which of the following pieces of laboratory glassware should be used to most accurately measure out 25 milliliters sample of a solution? Okay, you guys don't know this one because whenever we have had to measure over the last 2 years anything with some degree of precision, I've always used a burette. You've always gone to a burette and, made a note of the starting volume and then tried to release the amount you needed. That's because the pipettes we have aren't that good. You would use a pipette. Now, this is not like the little plastic, eyedropper thing. It's a glass pipette. If you want to see it, ask me in class. And then finally, 40 milliliter sample of 0.25 molar potassium hydroxide is added to a 60 milliliter sample of 0.15 molar barium hydroxide. What is the concentration of the hydroxide? Okay, they like to do this. They like to combine 2 solutions. These things are both soluble. And then you have to figure out the molarity of just part of it. So what I'm going to do, I'm going to figure out how many moles of hydroxide I got from the potassium hydroxide, how many moles of hydroxide I get from the barium hydroxide, add those moles together and divide by the total volume after those two solutions have been mixed. So 0.25 molarity times 0.040 liters is going to give me 0.25 times 0.040, that's got to be 0.01. 0.010 moles, that would be moles of KOH, but every KOH breaks apart 1 to 1. So that is going to be, that's the number of moles of hydroxide. But for the barium hydroxide, 0.15 molarity times 0.060 liters. 0.15 times 0.060, 0.15 times 0.06. Did I do that right? 0.15 times 0.06. Yes. This is 0.009 moles. Okay. Here's the thing. That's moles of barium hydroxide. That is not moles of hydroxide. 0.009 moles of barium hydroxide, and I get 2 hydroxides for every 1 barium hydroxide that breaks apart. So that 0.009 is getting multiplied by 2. 0.018 moles of hydroxide. I'm going to add these moles of hydroxide to these moles of hydroxide. That gives me 0.028 moles of hydroxide, and I have to divide that by my total volume. What I just did was combine 40 milliliters with 60 milliliters. That's 100 milliliters. I'm dividing this by 0.1 liters. So that should be 0.28. Bonk, right there. Okay, thanks guys.